This is the Kaggle notebook. So we have chosen this data set, Amazon stock data. We wrote this code and we got the path from here, Kaggle server path, directory path. Then we read the CSV here with this path by copy pasting. We store it in this DF data frame. Then we create a shallow copy of DF data frame in DF1. Then we modify the date as change the data type of date from date time from string to date time, then from date time to int64 type. So we got the so that we can get the date in the epoch time format, because previously it was in month, year and day time format. So we converted it into epoch time format from here. Then we got only these date and adjusted close columns from the dataset, because the dataset previously I will show you here. So dataset previously when we loaded it, it was like this, like df. When I show you the raw data, it is like this. Date, see, date. When we read df from here, let's run it again. Now see, date is in year, month, day format. So we converted this into like epoch format date in the data frame. It is not showing. Now see, date is converted here in epoch seconds format. These are the seconds, epoch format or date time. Then we selected only date and adjusted close from the data set, and we created data from df2. Then we set the index. We created this date column as the index, and we have this adjusted. We converted this into time series. This step is to convert it into time series. To convert into time series data format. Here we have the data now, 6257 rows and 1 column. Now we imported matplotlib as plt pyplot. Then we plotted this. We can see the adjusted close along the timeline is progressing as a exponential form. It is progressing as an exponential form. We have a pattern as a line plot as a exponential growth in stock price of Amazon data set, Amazon stock. So we'll create a markdown here. We created a markdown. We have a pattern as a exponential growth. So we will import from stats model.tso.seasonal import seasonal decompose. So we will decompose this time series as here it is exponential rise, the seasonality is rising. But so we will use the multiplicative model for a seasonal decomposition of this time series. So we will use here. So we will store the seasonal decompose in result, and we will use our time series data. Our time series data is df2 comma model. We will use multiplicative model for seasonal decomposition of time series. We'll use multiplicative model. Then we will use periods is equal to, as our data is in daily format, so we will see it in a seasonality. We will see it in a let's say we have how much data here. Data from 1997 to 2022. So let's see it in a year-wise period format. We'll use 365 as the periods, 365 days. So we'll see it the seasonality according to the yearly format, according to the year-wise period. We will see it. If you have to see it in 7 days period, then we will type in here 7. If you monthly, then we will type here 30. If quarterly, then we would have typed here 90. But we are have to see the yearly, so we'll type here 365. Now let's run this. One error is this. What I'm supposed to. This is period. Spelling is wrong. Result. Now we'll plot this result. Result dot plot lt dot show. Now we have our decomposition. This was our original series. Trend we have like this. The multiplicative model. Seasonality is like this. This is the seasonality. Seasonality is shown here like this. Then residual, the noise is this. The noise in the dataset is this. We have very high noise somewhat here around this starting point in epoch time format. That is somewhat in 1997 to 2010 between like this, 2005 between like this. We have very high noise. For the seasonality, we can see seasonality is going like this: first rise, then down, then rise, then fall, then rise. We have somewhat M-shaped seasonality. We have rise, fall, rise, fall. So